Hey guys, how's it going? Valentin Kuzub here, creator of ICMIZER. In today's video I'm going to be talking about the TrueBounty model which ICMIZER offers for progressive knockout tournaments. Now the TrueBounty model is a very complex model and this video is going to be an advanced video. If you are a professional poker player who is playing progressive knockout tournaments, then you'll definitely find out quite a few new information pieces in this video. I'll be talking about some advanced concepts like TrueBounty model, like bubble factors. We will be talking about the difference between ICM prize pool and the bounty prize pool. And the most important question which will be answered is the question, how does our equity change when we double up early on in progressive knockout tournament? And that will help us to understand the question, how much equity do we need to call early on? Because that has been a big question up until now. So to start, let's first talk about the intuitive approach to bounty prize pool, and the intuitive approach is the CPV approach. So how does that work? The CPV approach looks at the situation in a very simplistic way. So let's say we have 3 stacks. We have one big stack who has 1,500 chips and 2 short stacks who both have 10 chips. The CPV approach will assume that regardless of how the bounties are distributed at the players, whether or not they're located like here or like here, the equity will be the same for any combination of potential bounty distribution and will only depend on the stack size of the player. So if the big stack has 1,000 chips, which is 98% of chips out of this total chip pool, then the CPV model assumes that his bounty equity would be equal to the current bounty pool, which in my case is equal to $2,000. And the CPV will assume that his equity is equal to 1,974 chips. And the short stacks, of course, will only have $13 equity. Now, if you look at the situation closer, you will realize that there is no way for a big stack to get this kind of equity. We can try 2 different modeling ways for this. First would be if 3 players go all in at the same time. And as you can guess, there is no way for a big stack to avoid the chance that one of the shorter stacks busts the other and gets $500, close to $500 immediate bounty for him. So with that gone, there is no way our stack will be close to 2K in equity. And the other approach would be 2 random players chosen who randomly fight against each other. In that case, in 1/3 of cases, 2 short stacks collide, and again $500 is gone from the prize pool, and we again cannot get close to $1,974 in equity. However, we try. So this demonstrates in this quite extreme example the problem with the CPV model, that the CPV model significantly overvalues the big stack and undervalues the short stack. And this is similar to the CPV behavior in tournaments. ICM changes that. In ICM, the shorter stacks are more valuable and the big stacks are less valuable than the CPV model suggests. So let's look at the TrueBounty model and how it works in ICMIZER 3 and how it estimates the equities of these players. So these are results for the equities with the TrueBounty model. As you can see now, the short stacks have gone up almost 10x. The equity of short stacks is now $140, and the equity of the big stack is now only $1,720. So his equity is now only 86%, down from 98%. And as I said, there is a clear 1/3 probability that if we go 3-way all-in or these 2 stacks randomly collide, one of them busts another, and he gets that chance to get that his take on that $500. Of course, once he's gone, the other short stack, and we are alone versus the short stack, we will get pretty much the GPV equity. But when there are 3 players in such disposition, there is no way for us to get anywhere close to the GPV equity. So this demonstrates the problems with the GPV model when applied to bounty pool, and the benefits of TrueBounty model on this extreme example. Now let's look at the less extreme example and find out how it works in a more real-world situation. So here I have a situation where there are 2 short stacks who are both 1,500 chips, and we have 3,000 chips. And for this situation, we are going to be using minimal blinds, level 0 small blind and 1 big blind. And I've chosen these blinds in order to show you the equity which ICMIZER calculates for these stacks, and to demonstrate you how you can get the numbers out of TrueBounty model with ICMIZER. So I click on the push range for the small blind, and here I can click the detailed result button. In detailed result button, I can see that pre-flop equity for the short stack, in this case, is $3.90. And if we apply the default GPV approach to this, we can see that the total price pool is $15, so the GPV approach would grant the big stack $7.50, and both short stacks would get equal $3.75. But as we can see, the model, the TrueBounty model, goes like I told. It values shorter stacks more than the GPV model. Here the short stacks are valued at $3.90, and the double up outcome, the big stack, 3,000 chips, is worth $7.3, which is less than $7.5 in the GPV simplistic approach. So now let's talk about the equity which we need. So if it was the GPV, the bounty pool would have would grant us 100% equity when we bust someone. But in this case, as we can see, it doesn't. So I have prepared a special chart for you where I explain how this works. So when you're playing in a progressive bounty tournament, you are always thinking about 2 different parts of equity which your stack represents. Let's say you have these 3,000 chips, and now these 3,000 chips have equity in terms of prizes in the tournament, the payouts for the first and other finishes. Usually in the progressive knockouts, half of the buy-in goes into standard payouts, and half of the buy-in goes into bounty pool. So here we can see the interesting chart. Here I show how much equity we gain for the double up in each of these parts of our stack equity. So when we are talking about ICM early on, as you probably know in MTT tournaments, early on when you double up, you get very close to 100% gain. So because of that, we like to say that early on MTTs play similar to GPV. So here I have a chart for 90 players, and we can see that when there are 90 players and we double up, we gain more than 90% of equity, which is very close to 100% of equity, which you gain when you double up in GPV situation, like cash game or spin and go tournament, or a tournament with just 1 payout. And as you progress through the tournament, the actual gain that you get when you double up goes down. So as we get closer to the bubble, the double up may only improve our equity by something like 40%. This is why everyone is so tight on the bubble, because the won chips are worth much less than the lost chips. And the effect is mirrored in a completely different way when we are talking about our bounty pool equity gain. And this is what most players don't realize, and this is what this video is all about. So here I have a situation which I was showing you right now. When we have this 3-player situation and we double up, we can see that our equity is, like I've shown, it is, the big stack is worth 7.3 and the short stack is worth 3.9. So 3.9 times 2 would be 7.8. So as we can see, it is slightly less than 100% gain. And on this chart you can see that it is about 87% gain. But as the number of players increases, the gain goes down. So early on in the tournament, when you double up, your bounty pool equity doesn't double as it does in MTT and as it does in your MTT equity part when you double. But it only gains 67%. So this 67% gain is what we are talking about when we are talking about double up early on in progressive knockout tournament without the bounty which you get immediately for your for busting the player. We are talking about the equity gain of our double stack. So let me explain. Here I have an example of a 90-man $5 sit and go with 13 payouts, and the prize pool evenly split between regular prize pool and the knockout prize pool. So here we have this guy pushing into us, and I click ICMIZE and go into details to see how our equity changes when we win. So when we win, our equity becomes 2.3% of the entire prize pool. And if we fold, our equity is 1.09% of the total prize pool. So as you can see, when we win, we get the bounty, we double our stack, and our equity barely goes slightly more than 2x. So if it was 100% gain, it would be 2.18, but it actually is 230. I just told you that the gain early on would be just 67%, but I'm showing you that is more than 100%. Why? Because we get the bounty for busting the player. We immediately get $1.15 in our stack, which is a significant gain. And to see what happens if we don't get that gain, but we also double up. Well, we almost double our stack here. Yeah, we double up our stack if we win in such a case, but we do not get the bounty for busting small blind here because he will be live with one chip. And let's look at how our equity changes here when we win. Again, the pre-flop equity is 1.09, but the equity when we win is only 2.02. So this shows you that we do not double our equity early on in the bounty tournaments, and this shows that you should be quite cautious against opponents which you do not have covered early on in progressive knockout tournaments. And I believe most players are very excited to call, and they may be a little bit too wide here, assuming that they get 100% gain of their equity out of the bounty part of the bounty pool. To better understand what's going on here, I have this chart. So when the tournament starts, our stack is evenly estimated as half of the stack goes into bounty part of the prize pool, and the other half goes into payouts part of the prize pool. As the tournament goes and the players bust each other, but we are still not in the money, the bounty prize pool goes down. And as we reach the bubble, let's say we have a tournament with 90 players, like I show you, and we have reached the bubble with 14 players. It means that there have been 76 busts, and 76 bounties have been paid already. So the bounty pool has been significantly lowered from the start. It has shrunk, and now the bounty pool is significantly smaller than the remainder of the payouts pool, which hasn't been touched yet. So now our chips are much more related to the payouts than they are related to the bounty. So this is also what a lot of players don't realize. On the bubble of the Progressive Knockout tournament, the ICM is much more important than you realize. Everyone is very excited about bounties. We are looking like who has this bounty, who has that bounty. But you need to realize that as you progress towards the bubble, the pressure, the ICM pressure, goes up significantly. And the tournament may play, yes, the bounties of course play a big role. If there is a short stack who is pushing, then you definitely call him super wide. But you need to realize that if this isn't a super short stack, this is a big stack or a similar stack to yours, then ICM is playing a very important role. And if you don't have him covered, the double up will be affected by the this part of the chart, the double up, when the prize pool is taking a bigger part of our equity. It means that we are less inclined to call on the bubble in progressive knockouts due to the fact that we need much more equity to call because we do not get as close of a gain as we do early on in the MTT, like we do here. We only can get like 40% or maybe 50% increase. And yes, we get a better increase in our bounty pool. But like I show you with this chart, the bounty pool goes down. So these effects, which work in opposite directions, the role of this becomes more important as we get closer to the bubble than the role of this, where we are actually going up from the initial 67% all the way up to the 87% gain, which we get when we are left three-way. So why does this TrueBounty model work like this? Why it's not cheap EV? Here I have prepared a special example for you, which should help to better understand the problem which cheap EV isn't taken into account. So let's think about a three-way situation. Let's say that we are player one, and there are three, let's say we are thinking that only two players may go all in. And this is the way we are modeling the situation. So we have two squares, and if we go all in and the second player goes all in, if we go all in and the third player goes all in, or if second player goes all in and the third player goes all in. So in 2/3 of the time we participate in the action, and in that case we prevent the bounty pool from shrinking without our participation. But in 1/3 of cases these two players collide, and in our example with the 3,000, 1,500 chips, we can see that in 1/3 of cases they collide, and one of them will take away the $2.5 from the bounty pool with him instantly and it's gone, we cannot pretend to get that. So GPV model doesn't understand that fact. And as the number of players increases, we can see that if we are player number 1 in the second case, when we are 9-way, then we can play against all of the players. We can play against second player, third, fourth, fifth, sixth, seventh, eighth, and ninth. But we can see that now there are much more squares which represent outcomes where the first all-in which happens isn't taking us into account. And actually it can go hand after hand where we are not participating. It could be first hand, second player is versus third player. The bounty pool shrinks. Second, fourth player is versus fifth player. The bounty pool shrinks. And it can go like this for many hands before we actually get a chance to take part in the action. And we only can get part of the bounty prize pool when we actually take part in the action. But as you can guess, we cannot be forcing action. We needed to have a hand. And everyone has equal chance to have a hand. So the more players there are, the smaller there is a chance that we will be taking action. We will be contending for the bounty pool. And instead, other players will be contending for the prize pool. And this explains why this chart works like this. Why, as the number of players in the progressive tournament increases, the gain which we get for double stack goes down to this 67% level. So I hope this was helpful, and I hope you have learned something. And the next topic which I want to explain is the use of bubble factor and ICMIZER, and how you can use them to better understand the explanation of why you should be using this specific range in this specific situation, which is a popular question. Like, I get asked, why should I play like this here? Well, usually the answer is because of mathematics. We take into account stacks, bounties, payouts, number of players at the tournament, number of players at your table. And once that is taken into account, ICMIZER produces you with the correct mathematically optimal ranges. But if you want to better understand why they are like that, you can use the bubble factor. Now, when you perform ICMIZE operation, you will see these bubble factors next to each player. And let's look at the bubble factors when all stacks are the same. Here we can click on the bubble factor and we will see the bubble factor table. Here we can see that all players have a bubble factor of 0.95. Now, a bubble factor explains how much the won chips are better than the lost chips. And here we can see that won chips are actually much better than the lost chips, and we want to participate more than we do in GPV situations. Normally, in most tournaments, before progressive knockouts, we were less interested than in GPV situations. So in GPV, the bubble factor is equal to 1. The won chips are equal to the lost chips. And in usual entities, the bubble factor is usually more than 1. The won chips are less valuable as the lost chips. So here I have created a table which explains how much equity you need depending on the bubble factor. So if the bubble factor is 1, then you need 50% equity. And this is just raw equity, pure equity without any blinds. Let's say blinds are 0 and you're seeing an all-in in your stack, which is equal to your stack. How much equity you need to call versus opponent's range. If the bubble factor is 1, you need 50% equity. If the bubble factor is less than 1, as we can see in our example, it's 0.95, then we would need somewhere between 48 and 49 equity. As bubble factor goes down, we can see that the equity needed goes down. And you may think that this difference, like 4% equity here or 4% equity here, is not much. But in reality, if the bubble factor is bigger than 1, and the example which shows that would be when we actually do not have our opponent covered. If we don't have him covered early on and we are facing a push, our bubble factor versus him is actually 1.24. So when we look at the table here, we can see that we need 55% equity versus his range. Now let's see how that works. To better understand this idea, we can use the chart feature in ICMIZER. Let's say he pushes 100%. How wide can we call? We can only call with 35% hands in this case. Now, if he was 1,500 chips and we had him covered, then if he was shoving any two hands, our calling range would be much wider. It becomes 58%. So as you can see, just one chip significantly changes our eagerness to call here. But how to actually get a feel of this, how to understand how this bubble factor works? I'm going to build a chart, a range chart for this regard. And the range chart indicates how our calling range looks like when our opponent is shoving a certain percent of hands. So here you can see the chart. The call chart usually looks like a triangle with the height of, with our range being tighter than the pushing range. So here the pushing range is 100% of hands and our calling range is 35% of hands. If he is pushing, say, 50% of hands, then our calling range becomes like 1342, or half of the initial 30% of hands. So usually this triangle form helps you to understand that if you know that in this case, with this bubble factor of 124, your calling range is roughly 35% of the pushing range. If you think that your opponent is pushing, say, 40% of hands, then you can estimate that in your head while playing that you should be calling with about 30% of his shoving range, and if he's pushing 40%, then you can only call with 13% of hands. So let's see, if he's at 40%, we can actually call with 11% of hands. So we could do that math in our head, which is very helpful. And if you study enough with ICMIZER, you can do that kind of math in your head while playing. So let's look at the GPV chart in this case. We switch ICMIZER in GPV mode and build the same chart. So here we can see that in GPV mode, we can now call with 53% of hands versus 100% of hands, or half of the pushing range. If he pushes, say, 50% of hands, we can call with 27% of hands, which is also close to half of the hands. So this triangle shape of calling range is very helpful. And to better understand the difference between bubble factor in progressive knockout tournament and in GPV, as you can see in GPV, all bubble factors are equal to 1. Let's look at the chart again. We are calling here versus 100% of hands with 53% of hands. If we switch back to ICM mode, turn on the MTT mode and make sure that it's the same situation and build the same chart, we can see that now we can call with 57% of hands, which is wider than GPV suggests. And this means that this 57% range of hands will have the required equity, which is dictated by the bubble factor at this situation, which, as we can see here, is equal to 0.95. So that's how you can use bubble factors, the range chart, the TrueBounty model in ICMIZER, and this finally explains how much equity you need early on to double up. You get 67% gain in bounty pool and almost 95% gain in ICM equity pool. So if you throw in additional 50% equity for the immediate bounty, you get more than 100% gain in the bounty pool, and generally you get more than 100% gain in the entire equity. So that explains how to play early on. And one thing to keep in mind is that this is when we're talking about this kind of calculations, these are the immediate hand calculations. So actually you may think that when you call and actually double up, in the future you will have much better time versus your opponents with a double stack. And that is very true, but you need to remember that this doesn't mean that you are super excited to call, because when you call there is a 50-50 chance or significant chance that you actually leave the tournament immediately if you do not win. So if you do not win and leave, that's a very bad outcome for you. But when you double up and you have a double stack and progress knockout, that's a great outcome for you. So you need to think whether or not actual risk now is worth the potential benefit if you win, because you are not guaranteed to win. That's very important to realize. So this is something you can think about. This is something you can adjust to. If you believe that there is a good value in double up, you may actually call wider than ICMIZER suggests. So let's say here we assume that the small blind pushes, and let's say we hold a hand like fours, and we can see it's very small gain, only 9 cents in $5 tournament with a 40 cents rake. So when we look at the chance of our bust here, we can see that in 51% of cases we actually leave the tournament immediately. But maybe one could say that if they double up now, they will have a great time in future hands, and maybe it is worth this a loss of rake, which we can see we are losing 31 cent in rake immediately here if we lose. But if we win, we can say that maybe we are a better player and we will have big chances to bust other players. We will have them covered. Maybe that is worth it. So these are the things you should be thinking about. And again, let's talk about this chart. Remember that as you get closer to the bubble, or when you're in the money, the bounty pool has been significantly diminished. It's smaller now, and the ICM pool is usually bigger than the bounty pool, and in some cases bounty pool could be significantly smaller than the ICM pool. But everyone in progress knockouts seems to be super excited about the bounties and less excited about the payouts, and the combination of all these factors, of this tricky behavior of these charts, can lead you to only one conclusion. You really need a calculator like ICMIZER with a TrueBounty model in it in order to find the optimal solutions for complex tournament situations. Now, these tournaments have been complex by design. They are tricky, they are counterintuitive, there are many plays which you could make which would be wrong. Of course, the simple plays where short stack pushes with a big bounty and you call wide are simple, but most of other plays are much harder. And the bubble and the final table plays can be especially tricky, and you really need ICMIZER to do the math. So I hope you found this helpful and learned something new. Let me know what you think in this video. Let me know if you are still a believer in GPV approach in bounties. And if you liked it, click like, subscribe, and thank you for watching. Valentin Kuzub, signing off.